Okay, so we're going to start with group 7 elements, right? And the group 7 elements are, if you look at the group 7 elements, so the group 7 elements are fluorine, chlorine, bromine, iodine, and astatine. So if you go from the top to bottom, so this is the order of elements that you find, right? So the first uh, element in the group 7 is known as fluorine, and the last one is known as astatine. However, the periodic table has been recently updated, and I think the last element is something else, which you can just check from the periodic table. But these are the group 7 elements, right? And group 7 elements are also otherwise known as the halogens. Okay? They are known as halogens. Okay. So let's take a look at the physical properties of group 7 elements. So they're all non-metals. They exist as simple diatomic molecules, right? So they are all non-metallic, right? Because they exist on the far right of the periodic table. And we talked about the journal overview of the periodic table, that on the right side, we generally have the metalloids and the non-metals. And on the left side, we have the metals, right? So on the left side, we have the metals, right? And on the right side, we have the metalloids and the non-metals. Okay. Generally, we have the non-metals on the right side. So group 7 is located on the right side. That's why it contains non-metals. They exist as simple diatomic molecules in their free state. So, for example, if you take a fluorine, right? So all elements in the group 7 will exist in diatomic state. They'll never exist as separate atoms. So they'll always exist as diatomic state. Like, so always as F2. Fluorine will gas will always exist as Cl2. Bromine gas always exists as Br2, right? So they always exist in a diatomic state, right? Because it makes them more stable. Uh, yeah, so they have the chemical formula X2. So this is the chemical formula in the diatomic state, Cl2, Br2, I2. They all exist in diatomic state, right? So uh, all of the group 7 elements are attracted to each other by a weak force known as the van der Waals forces. That is not really important. We'll discuss more about intermolecular forces in a bit. But earlier I told you guys in earlier lectures that there are two types of forces. There are intramolecular forces. Okay, there are intramolecular forces, and then there are intermolecular forces. What is the difference between intra and intermolecular forces? Maham.
Are the intermolecular forces the forces that keep the molecules together?
Right? And intramolecular forces?
I don't know what that is.
Okay, so that's pretty simple. Intramolecular forces are basically the chemical bonds, right? So, for example, if you take a molecule of O2, so the covalent bond between one oxygen atom and the other oxygen atom is is what is called the intramolecular force, the forces that exist within the molecule. Intermolecular forces will exist between individual O2 molecules. One O2 molecule, the other O2 molecule, another O2 molecule. So the forces that exist between these molecules of oxygen are known as the intermolecular forces, right? And one of those intermolecular forces is the van der Waals force. This is the weakest of all intermolecular forces. There are many other intermolecular forces which we'll talk about later. Okay, so the strength of these forces increases when the molecule's size increases. Okay, so if the size of the molecules increases, the strength of this intermolecular forces increases. And that's because when your size gets bigger, right? So you have a much more uh, dense electronic cloud, right? So for example, if you take a molecule of chlorine, right? So chlorine has like two chlorine atoms, right? So it has like This chlorine atom has this electrons that are orbiting this chlorine, and it is sharing some electrons with the opposite chlorine, its neighbor, right? So the chlorine molecule has this electronic cloud, right? And electrons are constantly orbiting in this cloud. So chlorine has this electronic cloud. And when it comes in interaction with another chlorine molecule, so for example, there's another chlorine molecule in its vicinity. So what will happen? What will happen? So the the thing is that when another chlorine molecule comes near another chlorine molecule, so tell me, what is the charge on the electronic cloud? जल्दी से माहम इलेक्ट्रॉनिक क्लाउड पे क्या चार्ज होता है? नेगेटिव और पॉजिटिव?
Negative.
Right, negative. सही है. So this electronic cloud is negatively charged. What about this electronic cloud? This is also negatively charged. So when this chlorine molecule will come near this other chlorine molecule, it will kind of repel this portion of the electrons, right? It will kind of repel this portion of electrons to the opposite side. Okay, okay, like charges, they will repel. So what will this create? This will create a relatively positive zone here and a more negative zone here, right? This is known as a dipole. Okay, this is known as a dipole. And a temporary dipole will be created, right? As long as this chlorine molecule is near the vicinity, in its proximity, this dipole is created. And this dipole and the opposite dipole will be created on the other end. Say, for example, right here it will be negative, obviously, and this will be positive, right? So what will happen is that these molecules will start attracting each other because the opposite poles of the dipoles are attracting each other, right? So these are known as the dipole to dipole interactions, right? And this is what also is the concept behind the van der Waals forces. So, so let's move back on to why the magnitude of the force increases as the size of the molecule increases. Why does that happen? That happens because, tell me, अब रफी आपने मुझे बताना है. अब अगर फॉर एग्जाम्पल किसी मॉलिक्यूल का छोटा इलेक्ट्रॉनिक क्लाउड हो, ठीक है, फॉर एग्जाम्पल क्लोरीन है, उसका इतना सा इलेक्ट्रॉनिक क्लाउड है, उसमें इलेक्ट्रॉन्स कितने होते हैं क्लोरीन में? 17 ईच, राइट? 17 इलेक्ट्रॉन्स इसके पास है, 17 इलेक्ट्रॉन यहाँ पर है, 17 इलेक्ट्रॉन यहाँ पर है, ठीक है. टेल मी द इलेक्ट्रॉनिक नंबर ऑफ इलेक्ट्रॉन्स इन ब्रोमीन, जल्दी से. बल्कि ब्रोमीन नहीं, आयोडीन है, बताना आयोडीन में कितना होता है. ओके, सो आयोडीन हैज 53 इलेक्ट्रॉन्स, राइट?
Uh,
सो आयोडीन जो होते हैं ना, उसके पास 53
the
इलेक्ट्रॉन होते हैं, राइट? तो इसका मतलब हर आयोडीन एटम के पास 53 ईच. तो किसका इलेक्ट्रॉनिक क्लाउड ज्यादा बड़ा है? विच वन ऑफ देम हैज अ
iodine का.
आयोडीन का, एग्जैक्टली exactly. अच्छा, अब मुझे एक और बात बताना, माहम, आपने बतानी. इफ यू ब्रिंग another iodine atom, ठीक है, नियर दिस आयोडीन मॉलिक्यूल, सॉरी, एन आयोडीन मॉलिक्यूल नियर दिस वन, so will a larger will the duration of that dipole that is created be larger in the iodine or the chlorine? Because just imagine so many electrons shifting to the opposite side just because another I2 iodine molecule came near this iodine molecule. So it will create a temporary dipole, right? So a larger electronic cloud means the duration of that little perturbation in this electronic cloud will be larger, right? The duration will be much longer. So a dipole will be created for much longer duration, right?
टाइमर हो गया.
क्या कह रहे हो? अच्छा,
25 मिनट्स का टाइमर खत्म हो गया तो.
ओके ओके, सही है. सो अभी यहाँ तक समझ आ रहा है ना महाम और रफी आपको?
जी.
Right. So because of the
जी.
iodine's larger electronic cloud, सही है, that leads to a longer duration of the perturbation in the electronic cloud, right? And that creates a longer dipole. मतलब dipole जो है ना, the time during the time for which the iodine remains in that temporarily charged state, dipole state, is longer. And that's why the intermolecular forces, the van der Waals forces, are stronger in the iodine as compared to the chlorine, right? So as the size of the molecules increases, the duration of dipole increases, and that's why the van der Waals forces, they become much stronger, right? So ये है, अभी इन्होंने फिर से टाइमर लगा दी, खैर, so we'll stop here and we'll start another meeting, ठीक है?